Hello, sir. So my name is Salsa from Industrial Management, and in here I want to present my final assignment for my final project, machine learning and big data. So first of all, I want to explain the dataset that I will use in this project. In this project, I use data from the Kaggle. I found one data that's really nice for me is house price prediction by Surrey that updated 7 years ago. And why I want to use this data because this data have three things that I really needed into my project. The first is this data have the theme type information that which is really good for my time series forecasting. And then this data also have the continuous availability of price data that also make the suite able for building and evaluating forecast models. And this data also have the classification of the kind of the house, which is really good later for my model training data, for model training. And then this is my workflow for my project. So first, after I got my data from the Kaggle, I will import my data into the SQL server. When I already get into the SQL server, I will change the data type, also add the price level from the three different kind of classification. After that, I will make a data dashboard from the Grafana, so it make it more easier to see the visualization of my data. After that, I will do the data analysis using a Python in the Jupyter notebook. And still in the Jupyter notebook, I will do a four kind of different data forecasting. So I want to see the forecast of the average house price by trend using the linear regression. And second one, I want to forecast the price for the specific city by linear regression. And then I want to see the house price distribution for the next month by city. And also the last one, I want to forecast house price in the next month by city. After I do the forecasting, I will do the model training data with the three different kinds of the model. First is I want to use a logistic regression classification. Second one, I will use random forest classification. And the last one, I will use the gradient boosting classification. After I do the model training, I will upload my unzipped data into the MongoDB. And in the MongoDB later, I will demonstrate the data retrieval and the interaction using the CMD. So that's all for my workflow. Let's we continue to the import data into the SQL. This is the first step I do after I download my data. This is this is the output when I already import my data into SQL. So I have 4,600 entries in here, and then I have 18 different feature columns, which is, yeah, it's really big data in here. And after I got this data from 2014, from 5 months into seven, from June to August, from June into July, yeah, that month, I changed the data type first before I do some forecasting and model training with my data, because I want to make my data like having more better data type. So as you can see in the left, all of my data before is all feature, but I want to change it into more better to use. So if it's a date, that I will change into date time, and some of my data that have the decimal, I change it into the float, and if it's still a numerical, I change into the integer, and if still have a character, still I don't do the change. I still using the var char in my data. After I change my data type, I add the view, so I can make the level of the pricing. So in here you can see for my code, I create a view from the view for with a view house price level from my DBO data. But I make a two kind of the column. So the first column is a price numeric. I change my data that money before as a float, so it will become like this in the price numeric in here. And then I put I put my classification for the low, medium, and high. If my price of the house is less than 400k, it's become low. It's like between 400k to 650k, it's become medium. And if more than 660k, it will be high. So the output will be like this one. After I add my view, I make the Grafana dashboard so I will more easier to understand my visualization of my data. So I make a total 8 dashboard panels in here. 1, 2, 3, 4, 5, 6, 7, 8, and have a consisting 6 different visualization types like this one. I will explain one by one. So for the first panel, I make the time series panel, and this is my code for my time series panel. For my time series panel, I want to show the trends of the house price over the time using the date column in here, and the price numeric column as a value. After I declare my function, I group it. I group my price numeric as a date, so it's will showing like this graph. After I make the time series panel, I make the pie chart panel. So I want to count how much is the percentage of the each level that I have. So I select my price level column, and I want to count it as a total from my view, for my view in the SQL, and then I group it by price level. So I group it from the high, medium, and low. After I make the pie chart, I also make the bar chart panel. I want to see like the total average of the every city, so I can know like which city that have the most higher or the lowest one, the average price. So by using the price numeric column and the city column, I count the average price numeric as the average price in here, and then I group it by city and make it a bar chart. So it's more easier, like I understand like how much average each city. After I made the bar chart panel, I made the bar gauge panel. So this is the house I using the house house condition column. For the house, my house condition column is still using the integer, so it's your 1, 2, 3, 4, 5 in my data, but I don't want to put 1, 2, 3, 4, 5 in my data, so I change it with when and then function. If it's 1, it's become poor. If it's 2, become fair. If it's 5, become very good, like this one. After that, I count my average price number and show the total average price number by its condition, like this one. And then I make the gauge model panel. I want to make a gauge model panel for now the renovated and the not renovated house. So I use the case and when, because it's also integer data. If I have count 1 and 0, if it no or 0, is I say it become not renovated, and if it's 1, it will show renovated. And then I count all of the house pricing average by renovated and not renovated, and then show it like this gauge model panel. And then I make 3 different kind of table panel. So the first one, I want to make the discounting of from the highest to the lowest. So I already count. I make the count from the city, the average of the price, city and the state shape average price, and I make it for the highest to lowest by using the DEST order. And as the same as the order from the lowest to highest, I just change the DST into ISC, like this one. So it's become the most cheaper to the expensive. And this is the last panel that I made. This is a table panel for the most selling house city. So I count like a total house for each city that's selling into, and I order it by the highest one into the lowest one using DESC here. Okay, that's all for my dashboard using the Grafana. And then after that, I do the data analysis and forecasting using Python from Jupyter Notebook. First, I connect my data into I'm connect the Jupyter into SQL server. So this is my server, my database, and also before in the SQL, I also make the role of my user. So I make a role for user 7 in here. And this is the connection function data, and if it's already connect, it will print connect to SQL server, but if it is not connect, it will show connection failed. This data I'm using a PEODBC. So before I put the libraries that I will show later, some of the libraries that used in this code. After that, I make the query code. So this query code will execute the SQL query to rectify the house price and the related data from my view, and will load the result into the Panda data frame or the DF, this one. If I already got my DF from my SQL data, I can do the data analysis. And this is my data analysis. I do the DF hit. So I want to see the first few rows of my data with using DF, and then I use the DF info to show the information of my data, like how much is the data in my column, and is it have a null or not, and what kind of my data type is it. So as you can see in here, sir, my data type is already the same as the one that already changed before. And after that, I do the DF describe. So I want to describe my statistic, all of it. So it will show how much the data is for the each column. So it will show the count, unique, how much is the unique code, unique data, how much is what is the top one, the frequency, the mean, the minimum, the quarter one, quarter two, quarter three, the maximum data, and the standard deviation of my data. After I analyze my data, I make the plot of the price level. So I want to see like how much is the data by the price level from the low, medium, and high, like this one by using the plot function. And after that, I also make the plot for my data distribution. So I want to show the distribution of house price over the time. So by using the DF date and the pricing, it can show like the distribution of the each data. And this another second code, this code is need to be put into the every end of the data, the function data, because this is the standard Python entry point. If I'm not putting this, so my script is not gonna run into the main function. It can be read my main function in the first row, and it cannot read the df of the data in the SQL. So I need to put this every time in the end. So this is my first forecasting. I want to forecast the predict the next 3 months house price by the average, all of the average house. So in here, I change my data, my data into the period first, and then after that, I count the total, all of the average in that time, the total average house in that time, and then make the prediction by using the linear regression to show the how much is the price of the house, each house in the next 3 months. Yeah, I just want to know the 3 months in here, so I just add 3 months. And then this is the second type of my forecasting. I want to forecast the specific city in here I want to predict the velocity. So I put the velocity in here. And after that, um, I want to predict next 6 months of the price of the price house in the velocity using the linear regression in here. And this is the range for the next 6 months. And after that, this is the code of the making this plot. And then the third one is I want to forecast the house price uh, by the months. Only in the predict data for the each city only next month, only 1 month. So in here, it show my data for the it is gonna count the next price month using the linear regression. So and then this code is will be show like how much is the price for the next month by each the city. And after that, I make the kind of the forecast distribution in here. So this is my distribution forecast house proportion for the each city. And the code 2 is the distribution of the how much is the exact forecast price per city. This one, so I can see like the visualization of it. After I do the forecasting in the Jupyter, I will do the model training using the Python, but from the Visual Studio Code. So I make the SRC folder, and there is around 5 different code PE. So the first one is analysis PE. So this code will provide the utility function for the basic data exploration and optional model explainability. So yeah, I will import the data, the pandas as a PDs, the library, and then for the data handling, I import the SARP. Before it, I already install the SARP and scikit-learn in my computer, so I can import the SARP here. And then after that, I describe the statistic for the data, so it will show the data profile, like how much is the missing data or the unique data. After that, I use the sub analysis is for the calculate the sub values and for the retrain model. This one. And the second code is data loader. So this data loader, it will extract the zip file. So this code defines two utilities function for handling zipped data files and loading CSV data. So there is a two function here, the extract zip, this extract zip to extract my zip file, and the second one is the load data. So I will load the CSV into the pada data frame or DF. And the third one is a model train PE. So after I put all of those libraries, there is two functions to train and evaluate the machine learning classification models. So in here, there is a train models. So after I split my data into X-train and Y-train, I train my data into three models that I want to train. First is logistic regression, second one is random forest, and the third one is the gradient boosting. After I train with this training models training function, I do the evaluate model, so it will be shown the accuracy and the scores of my training model. And then there is a pre-process code. So this pre-process code is to convert the data frame into the categorical variables into the dummy or one-shot encode columns. So by using the levels in here, it will split the data for the X and Y. So I can train for the X feature and the target feature by Y. So in here, I drop the every column. In here, I make my Y target is the level of the low one. Yeah. I put my train as a target is from the level. So my level is my it will become my my target column. And this is my main PE. So this main code is will run all of those data science pipeline from extracting into loading, and then it will print the descriptive data and the data profile. Also, it will be it's gonna become the main block runs this pipeline using the specific zip file and the target column. Before it, I already put my zip file into here, into my code folder, so it can be um, unzip. So this main PE will unzip all this main PE will run all of those that for this all code from the unzip into training, and then the target is I want to show the make it the level one, because this is the classification model, so I use the classification as my target. After I run my main PE, this is the output of it. So the first output is the script stat. So this is the output from this print the script statistic, this one. And then the second one is the data profile. So this data profile is the output from the data profile DF. And this is the model. So this is the model output. So the trains model start to training, but yeah, the iteration is start automatically because the iteration reach the limit. So it means that the data will be trained after this. And this is also the code output for the run main PE, but this is the score from the model. So this is the result of the three type of the each model from the logistic regression, random forest, and the gradient boosting. And the second score is the gradient boosting correlation classification report. And this is the evaluation score, the summary of my model training. So it shows the logistic regression, random forest, and the gradient boosting result of the of the training. It seems really good for me because it's like 0.92 accurate, 7 accurate. So this model training seems really accurate. Okay, after I do the first step of my training in the SRC, then I want to also make it more correlate to my MongoDB. So I want to, after I train my data in the Visual Studio Code, it will input automatically into the MongoDB. So there is like a modification for the code for the MongoDB. So I make a new folder SRC MongoDB in here, and the analysis is still the same code, but the data loader have a different modification in here. So this data loader is gonna handle extracting zip files that contains the large CSV, and it will split into 100 smaller CSV chunks and load those chunks into the MongoDB collection. So the first, when already extract zip, it will split the CVS using the specific, and then it's gonna load into the MongoDB with import CSV DRI to MongoDB. After this one is the split one. After the split, it will import CSV directly to MongoDB, and after import CSV directly to MongoDB, the dev will load the data into the PB, so the DF can be trained. And then this is the main code for the MongoDB. There is no such as so many, just like a previous one in the SRC, just a little bit different in here. The if is a main is a modularization into the spirit function, so it's not really have the significant difference. But yeah, we still gonna run the main code in here. We run main PE from the SRE MongoDB. So this is the result of the running that code. So this is the output code for the MongoDB, the SRC MongoDB. So it will still show the descriptive start. This is the output from the descriptive start here, and this is the data profile output, and this is the model that gonna start to train. And then this is the model training output. So this is we have the scores after we run our code in the SRC MongoDB, and the result in here, yeah, it seems really well because the accuracy is like around 16% to 68%. So the logistic regression is the best in here with a 68% accuracy, and it's balanced precision in here. And then random forest and gradient boosting are still good because have a 96% of the accuracy, but the logistics regression is more better than the random forest and the gradient boosting. Okay, after that, this is the chunks file that are displayed. So this is in my local disk program file code data chunk. This is the data chunks that already separate into this chunks. We can see this into the file explorer, and this is already split into 100 CSV chunks. And then the data also upload to MongoDB because we have the function to upload it to the MongoDB. So before we run the code, the local host still doesn't have any home DB, but after we reload it, it will show the home data in here. So the data will be loaded as much as 4,600 data that load into the MongoDB. Okay, that's it for the MongoDB upload and the data training code. So we're gonna go to the data analysis in the MongoDB. So I want to find like some of data, how to input and delete some data in the MongoDB. So first, of course, with using the CMD, I connect into the MongoDB by using the Mongos. After I put this file paste, I put the MongoDB Mongos, and then it will connect to my my MongoDB, and then we use the home DB, our DB, and then it's already switched into the home DB, so we can now find some of the data that we want. So the first is I want to find a home in the specific area. So I want to find the data I want to find a house in the Raymond city, but I want to have a lower price level and have a 2-bedroom. This is the code of it, and after I run it, it shows 6 different data that have the house in the Redmond have a low level and 2-bedroom. Yeah, this is 2-bedroom, 2-bedroom. Redmond City, and also low level. And the second one is I still want to find a home in a specific area, but in here I'm not find into some city. I want to find from the criteria of the house. So I want to have the house that have a 3-bedroom, but the floor have a 1.65. But this 1.5, it's because this is the having the decimal in here. So I want to make it become a string by adding the pick 2 dots up, and then after that I want to find the house that have a view of 3 and condition of a good condition, and then it will show one house that have that criteria in the Renton. Yeah, we have this house that have in the Renton. After that, I want to find home in some price range. So I want to find the house in the portal, but have the specific price range from start from 400 key into 413 key. So I use the price sum GTA and LTA as the equal operator that's greater than or equal to, and LTS mean less than or equal to. So it will be show the house in the portal. This one, this for house, but have the price range from 400k into 300 430k. After that, I want to find the most expensive one and the most cheapest house. So I want to find in the fall city, I want to find the most expensive one and the cheapest one using the sort and limit one. If we use the limit one, it's become expensive one, and but if we use the limit one, it's become the cheapest one, like this one. So if the numeric is -1, it's become, we can see the most highest price is uh 1.600k, and for the cheapest one with price numeric 1, it have 275k the price in the fall city. And after that, I want to delete some city data by using delete. So after I want to delete all of the data that include the city Raymond in here. So before is my data is 4,600, and I want to delete it. After I run this code, the output will be delete connect 235 data that I that removed to my datasheet. And then if in the MongoDB compass, it will show this one. So the data already only 4,365. So the red one is already gone. But if I want to add some of the data, so before it my data is 4,365. I want to input one data. So this is, I want to insert one for my other house in the red one. After I run this code, so the output will be I. So if we find the city Redmond in the MongoDB compass, it will show this data. Yeah. So this command to insert some data. So from the 65 is become 66 because add one data here. And okay, that's all of my presentation, and I will show my project. So first is I want to show my project in the SQL. So this is the SQL. I already run this code and it's already select top 1000 data, and then we gonna make the view because we don't have the view here. In here, I will run this code, and then it will comments completely successful. And then after that, we refresh this view. Yeah, and then we can see the DBO view house price level. This one. So it will show the view house price level that already have the level. This one. Price numeric and price level. After that, yeah, this is the data that I already input to my SQL with from the Kaggle datasheet as 3 house data. Because my internet is too low, maybe it's gonna be have a loading like a little bit slow. Yeah, I already download this Kaggle, and then we go to my dashboard in the Grafana. So I will go to my dashboard that I already have been made. So this is my dashboard. It's gonna be like this. So this is the trends of over the time. And this is the house price distribution, and also this is the average of house per city. And this is the house renovated distribution, and another panel that already been to make. But in my configuration, my data source, this card, I don't want to change it. I already connected to the SQL connection. So this is my host, my database, and when I already saved and tested, it's already data source already updated, so I can use the database from my SQL that make all of those my dashboard. Yeah, this is my data that I use in my SQL. I will close this. So, and after that, I want to predict my data. So this is my library. So I import some of the library in here. And after that, I do the data visualization. So if I run this, so first we're gonna connect into my SQL server. It's already connected to SQL server, and then it will show the analysis of the data here. It will show the analysis of the data and also the plot that I want to make, this one. And after that, we do the forecasting, but I just changed a little bit into the query. I use the columns that we'll use in the forecasting, only date, city, and price number. I'm gonna run this code. So it will show the forecast of the average price house for the next 3 months. It will show like this. And this is the data. This is the forecast for the city. I will run it. So I want to see from the fall city. And maybe if I want to try in the settle, I want to try to change into settle for the next. Oops, sorry. Where is it? Oh, this one. So I want to change into settle. Let's retry. In the settle city, it will change into the settle city, of course. Is it? Seattle. Oh, sorry. Seattle. This must be right. Now we can see the Seattle house price in the next 6 months. And then this is the forecast for knowing the each of the price in the next month by city. So this is the by city, the price by city, and this is the forecast house price distribution next month by the city. As the same as this one. So I also want to forecast the house price in the next city, in the next month by city, but I want to make it into the Gantt chart like this one. So this is all of my forecasting. And then I will show to the model training. So after I'm already run this. So after I run the code from the SRC only, so it will show the output like this one. And then this is the model that I run from the SRC MongoDB, so it will show this one. So this is the model evaluation score that I already explained from my PPT. And we go to the MongoDB. I think I'm gonna close this. Oh, sorry. So this is the MongoDB. Before it, there is no home DB, but I will refresh it. I will reload the data. And then the home DB already show because I already run it. And then this is my home data, this one. And then before it, I already I already uh wait a minute. I already prepare some of the MongoDB finding. So I want to try to find some data. So I will try to find the Redmond low with the 2 bedroom only. Oh, wait a minute. Maybe I will try it again. Copy this. So we're gonna connect to the file location, and then we start the Mongos, and then we use the home DB that we already have. So it's already switched into the DB home. We try to find the home in the specific one. This one. And then it will show the data that we want to see in the Redmond law. And after that, I want to try to find another specific criteria. And then it will show the house that I want that have 3 bedroom, 1.5 floor, and 3 view. And let's we try to find some price range. Oh yeah, and then this pretty, I put this pretty function, so it's gonna make my data is more look pretty. Yeah, and then this is the output of the data that have the price range of 100 key to 430 key. And then we gonna find the most expensive one in the city, right? And this is the most expensive one, and then this is the cheapest one. This is the cheapest one, and then I want to try to delete the city Redmond. It's already deleted now. I want to check it. Oh, sorry. I want to check it into my MongoDB. So let's retry to find city. Uh, Redmond. Wait a minute. Oh yeah, yeah. It's supposed to be like this. City Redmond. I want to find it. There is no result because I already deleted. But if I want to insert one house, let's insert one more. I'm gonna insert it. Oh, wait a minute. It's already inserted. I'm gonna go back to my MongoDB again and find it. And then it's already inserted. That's all for my presentation. And yeah, this is all of my project. And I hope I already do well for this project. And thank you so much for the learning and everything that already been teaching for me. Is really help for me to make another skills in the industrial management. Thank you so much and goodbye.